Good afternoon, sir, Vani sir, and Patil sir. This is our VDS assignment. Our VDS assignment, the topic is vehicle dynamics of off-road vehicles, and the vehicle that we have chosen is tractors, agricultural tractors. Let's look at the team members. Yeah, these are our group members. We are group 4. Just registering it over there. Getting into the presentation now. Yeah. The problem statement, why choose agricultural tractor? What are we going to do in terms of agriculture? What kind of vehicle dynamics analysis are we going to do on the agricultural tractor? Basically, we have chosen 5 parameters which would, when put into a particular equation, will yield the tractive efficiency of the tires used in a tractor, agricultural tractor. These values we are finding out because the important process involved in agricultural process is harvesting and plowing on tilled lands. Tilled lands is when you are done with the previous harvesting and you move on to the next harvesting. That is when the land is tilled, and the process that precedes these two are plowing and harvesting. For these two are the most important processes in terms of agriculture, and the amount of financial burden that lies on a farmer for these two processes is more. So by doing a proper vehicle dynamics analysis for these two processes, in terms of the tire specification, what tire to use, what dimensions of the tractor would be a right choice for the vehicle, we can proceed to reduce the financial burden on the farmers. So moving on to why the agricultural tractor. Yeah, the reason why we have chosen agricultural tractor, as I stated before. Agricultural tractor is a sophistication for any farmer. So if he is able to afford that, means that he needs more productivity. For him to attain more productivity, we need to provide maximum vehicle dynamics improvisations, so that there is no more financial burden than that he already has. So coming to that, we will be taking 5 parameters, which we will be seeing later on, finding out the values of those parameters based on the dimensions of the tractor that we have chosen. Apply those parameters onto a final tractive equation, find out the value yielded by the tractive equation, and then verify with an already existing predetermined standard graph to see if that particular vehicle with that particular front and rear tire specifications would be suitable for plowing on a tilled land, plowing and harvesting on a tilled land. Moving on to the next slide. Yeah, the tractor model that we have considered is Mahindra Yuvraj. The reason going for Mahindra Yuvraj is in most of the agricultural lands in northeastern and Indo-Gangetic plains, people prefer Mahindra Yuvraj for the plowing and harvesting. This seems to be a very trusted brand for tractors. So analyzing this particular tractor would end in benefiting a lot of people who already own this tractor, which tire to use and all this. The specifications, as in the dimensions, the tire dimensions, the capacity, the power, takeoff, all those are mentioned. The tires that we have considered for this particular tractor is, tires is something that is retrofittable, we all know that. The tires that we choose, this is after the result that we have chosen are, for the front tires we have chosen 600/65/34 TRS14, and for the rear tires it's 70.5/25. Yeah, the parameters that we'll be looking into are, the first one is slip angle. Slip angle is basically when there is a difference between the vehicle speed and the tire speed, there's something called slip that is being produced. And at what angle this slip is being produced, that we are calculating, so that using other parameters we can reduce this particular slip angle to improve traction. Next parameter we'll be looking into is tractive efficiency. That is how efficient the tires are in providing the traction in a tilled soil, where it is muddy and where there is chances of skidding and slipping to occur. Tractive performance is the out of the power output produced by the engine, how much is going in for the traction. That is, it should be like the least amount of power should go in for the traction. So tractive performance should be more when that is happening. Dimension analysis is basically analyzing the dimensions of the tractor so that the tire dimensions suit the dimensions of the tractor. Finally, finding out all these values and putting into the traction prediction equation for comparing with the already pre-existing graph.
Hello friends, my name is Kush, 13 BMS 17. I am going to explain slip angle today. Slip is S Vt minus Va upon Vt, which is basically Vs upon Vt. And shear displacement and slip, Vt is the theoretical forward travel speed of the vehicle if the rotational motion of the driving axle was perfectly transformed into forward motion, and Va is the actual force traveled speed obtained. A slip of 0 indicates the theoretical and actual speed of a vehicle, which the slip of the vehicle is the slip of the tire is 1 to 100. Percentage indicates the actual speed Va, which has gone to 0 and traction device is spinning with no further motion. Vs can be thought of as the velocity at which the shear displacement of the soil takes place. And this is the graph which indicates the maximum pull force of the function f, and W 10 phi, and the 10 phi of the slip is directly proportional to it. And this is the definition for the slip. The axle torque and the net tractive force are plotted as the function of the wheel slip, expanding on the definition of the slip for the given equation, and the same equation is given. And these are the further calculations which we did, which we got, the values we got from the agricultural tractor speed limit regulations of UK government, and the further calculation will be conducted by the same.
Hello friends, my name is HITEN BANSAL. I will be explaining about tractor performance of the tractor. We have basically chosen 3 terrains to calculate a very optimum value of tractive coefficient. Basically the tractive coefficient is pull by weight ratio, and the value of rolling resistance coefficient also comes out to be 0.1 for the same terrains. Now coming to the graphs, we see that these are the 2 basic graphs. This graph shows the net traction pull of the 3 terrains. We have chosen 3 terrains, and the 0.3 value comes out to be the most optimum value for the 3 terrains. This graph shows the rolling coefficient between the 3 terrains, and these 2 graphs is the surface for tilt surfaces. This is basically, we need this is more actual graphs for calculation of our purpose, because they show us the values in details. We also see that at 0.275 of travel reduction ratio, we have the optimum ratio of 0.6 between the traction ratio and the tractive efficiency ratio. Motion resistance ratio is independent of slip percentage of travel reduction ratio. All these calculations were made for the following parameters, which is axle weight is taken to be 8304 kgs, pressure is taken to be 83 kilopascal, and the surface is still, because we need the surface for our calculations to be tilt.
Hello everyone, I am AMBUJ TIWARI, and today we are doing presentation on vehicle dynamics of excavation vehicles, in which we are covering tractors which are used to plow land and harvesting tractors basically. These are used on tilled lands. We have to explain 5 parameters in this, out of which I am explaining dimensional analysis. Now we are taking the tire specification as 664 by 36 14 TRS. Let us see the calculations. The final deflection for the given parameters has been verified with values from Sara Slit et al. And found suitable for above mentioned applications. This is my dimensional analysis. We have width to diameter ratio, deflection ratio. Now where B is tire section width, D is diameter of tire. Now front wheels, these values we have got from a table which was basically used for tire designation. Width to diameter ratio we have calculated, which came 0.36. Then this was for front wheels. Then now for rear wheels we have B and D from the same table. Then the width to diameter ratio came 0.608. Then deflection ratio we need to calculate, where del is deflection, H is section height of the tire. Now PI is tire inflation pressure, W is weight of the vehicle. we have this formula for deflection. Weight of the tractor which we are using is 1380 kgs. Now for deflection ratio for front wheels is this. Deflection ratio, we have taken the values of PI and all from the table and we have put it in the formula. We've got the deflection ratio 10.41. For rear wheels, similarly we have got this, which is 2.93. These values we have checked with the Sara slit paper and which we found suitable.
SUNDARESH. This is my part, deals with traction prediction equations. So far, we have attained the parameters of B, D, H and delta, which we'll be putting onto these equations. All these equations together will form a number called mobility number, which we'll be using for finding out values on the graph. Bn is the mobility number, μg is tractive resistance, and P is the motion resistance ratio. The Ci, which we use for calculating mobility number, different Ci is given over there. We are choosing the one for plowing and harvesting on tin plants. These are the formulas for μg and rho, which is given for bias ply tires as well as radial ply tires. We are going for bias ply tires because the tire specification specifies that ours is a bias ply tire. This table is from a research paper where the different parameter standard values for front and rear wheel specifications are given. Taking the values of B, D, H, Ci, we have found out that the mobility number obtained is 3.46 and μg and rho are 0.296 and 0.556 respectively. Now verifying into the graph which is already available, predetermined graph, we found that the values are plotted and we can see that for the obtained value of mobility number, the motion resistance ratio is almost in match when plotted on the second graph. The calculated slip value also matches, and thus we can conclude that the chosen tire specification and the tractor dimensions matches the need for plowing and harvesting. So this finally results in optimal.
Good afternoon everyone. I'm TANVEER 13DM0019 and I will be explaining you about the tractive efficiency of the tractor and the particular tires that we have taken into consideration. The basic formula for efficiency is obviously output by input, and this output is defined by HVA, which is traction, net traction force and actual forward speed, and VA is the actual forward speed. The T and omega, the T is the torque and omega is the angular velocity. Now when we come to the final formula, that is 1 minus rho by μg into 1 minus s. This 1 minus rho by μg is the efficiency of converting the axle torque into the net traction, and s, as you already know, is the slip of the vehicle. You have to get the efficiency from 1 minus s itself, but why do we need that 1 minus rho by μg is the actual factor that determines the traction efficiency of the tires, which indeed gives the total tractive efficiency of the vehicle, or here a tractor. Now going on to our calculations that we have performed from the values that we have taken from the predictions, that is μg equal to 0.296 and rho equal to 0.556. The efficiency that we are getting is 70.24% for the traction. Now when we compare this value in the graphs that was explained to you by HITEN, we get the travel reduction ratio to be from 0.04 to 0.20, and this range has to be satisfied for a particular vehicle for optimum traction. And the net traction ratio comes within the range of 0.25 and 0.5. Now when we go for particular loads, that is at 6 psi load and 28 psi tire pressure, the net traction ratio is 0.3, and at 6 psi load and 6 psi tire pressure, we get the net traction ratio to be 0.4, which is a very optimum value as compared to the graph for a tilled surface. Now when we're going on to the final results that we have obtained from the whole process, we get to know that the predictions that we have taken to find the dimensions, to get the slip, to get the tractive efficiency, the performance, they all comply and conform to the graphs, and we get an optimum result of all the tractions, stability and the vehicle structure and dynamics of the tractor for the respective tire specification. So with this we conclude our presentation. Thank you very much.